Welcome to AMAC KSSM channel. This is KSSM at Max Form 5 exercise discussion. I'm Madam Wong here. Summative exercise 1. A particle moves along a straight line from a fixed point O. Its displacement s meter at t second after passing O is given by s equals to 2t cubed minus 24t squared plus 90t. Calculate A. The distance in meter of the particle from fixed point O when t equals to 8. So although he says distance, but he wants the distance of the particle from the fixed point O when t equals to 8. So basically we can find the displacement when t equals to 8. Sub in t equals to 8 into the displacement function, we have 2 times of 8 cubed minus 24 times of 8 squared plus 90 times of 8. Then we get 208 meter. B is velocity in meter per second when t equals to 1. So from here, we only have displacement function. And from the displacement function, we need to differentiate to get the velocity function. So we get v equals to 6t squared minus 48t plus 90. Then when t equals to 1, the velocity equals to 6 times of 1 square minus 48 times of 1 plus 90. Then we get E equals to 48 meter per second. C. Acceleration when t equals to 3. So again, we need to get acceleration function from differentiation of velocity function. So we get 12t minus 48 for acceleration function. When t equals to 3, the acceleration equals to 12 times 3 minus 48, and we get negative 12 meter per second square. D. The value of t in seconds when the particle stops momentarily. So when the particle stops momentarily, v equals to 0. So the velocity function equals to 0. We factorize the 6 from here. We get 6 times of t squared minus 8t plus 15 equals to 0. And we can factorize the t squared minus 8t plus 15 with t minus 3 and t minus 5. So we get t equals to 3 and t equals to 5. Question number 3. Elisa cycles passing her house and to shop along the straight pedestrian path. The displacement s meter from her house is at t minute is given by s equals to 2t cubed minus 9t squared plus 12t plus 6 for the period of time from 0 to 4. Assume the motion to the right is positive. A. Calculate number 1. The initial velocity in meter per minute of Elisa. So we are given the displacement function and we need to get the velocity. We need to do differentiation. And we will get v equals to 6t squared minus 18t plus 12. So the initial velocity happened when t equals to 0. So we sub t equals to 0 here, we get v equals to 12 meter per minute. Number 2, the velocity in meter per minute of Elisa when t equals to 3. So when t equals to 3, v equals to 6 times of 3 squared minus 18 times of 3 plus 12. Then we get 12 meter per minute. Number 3, the acceleration in meter per minute square of Elisa when t equals to 2. So when t equals to 2, we need to get the acceleration function by differentiate the v. So we'll get a equals to 12t minus 18. So when t equals to 2, a equals to 12 times of 2 minus 18, and we'll get 6 meter per minute square. Number 4, the distance traveled by Elisa in the 7th minute. So in the 7th minute, we need to find out the displacement when t equals to 7 and the displacement when t equals to 6. And we find the difference between these two times. So s equals to 7, we get 2 times of 7 cubed minus 9 times of 7 squared plus 12 times of 7 plus 6. We get 335. And when t equals to 6, we get 2 times of 6 cubed minus 9 times of 6 squared plus 12 times of 6 plus 6. We get 186 meter. So in the 7th minute, alright, in the 7th minute, a particular minute there, okay, the distance traveled by Elisa is 355 minus 186, we get 149 meter. Okay. Then number B, sketch a velocity time graph to represent Elisa's journey for t from 0 to 4. Okay. So when t equals to 0, we'll get velocity equals to 12. So we have 1 point. And then when v equals to 0, we know t equals to 1 and t equals to 2. So we have a smiley face, okay, because of positive 6, we have a smiley face with the roots of 1 and 2. So we can roughly sketch out our graph, okay, and we need to know what is the velocity here. So we need to sub in the 4 into the velocity function, and you will get v equals to 36. So this is the complete graph, and please mark down your minimum point. Okay, so the minimum point here, the t-axis is between 1 and 2. So we use 1 plus 2 divided by 2, so we get 3 over 2. And the v here, oops, use your calculator, and we'll get negative 3 over 2. So the minimum velocity is negative 3 over 2. Oops. In fact, I have calculated here. Alright. So this is the complete graph of velocity time graph for Elisa's journey. Question number 5. A particle moves along a straight line from a fixed point O for t seconds with an initial velocity of 8 meter per second. The acceleration a meter per second square of the particle t seconds after leaving O is given by a equals to 6 minus 60. Calculate. Assume motion to the right is positive. A, the velocity in meter per second of the particle when t equals to 2. So, from the acceleration function, we need to get velocity function by integrating the acceleration function. So we do integration. For the 6 minus 60, we'll get 60 minus 3t squared plus c. And the c, okay, will be 8 because this is the initial velocity. So the complete function of velocity will be v equals to 60 minus 3t squared plus 8. Now we can sub in our 2 to find its velocity. So when t equals to 2, v equals to 6 times of 2 minus 3 times of 2 squared plus 8, and we get 8 meter per second. B, displacement in meter of the particle from O when t equals to 5. So we have velocity function and we want displacement function. We do integration with respect to time. So from here we'll get 3t squared minus t cubed plus 8t plus c. And the particle is on the fixed point O when t equals to 0. Therefore, the c equals to 0. So, s equals to 3t squared minus t cubed plus 8t. Now, when t equals to 5, the displacement will be 3 times of 5 squared minus 5 cubed plus 8 times of 5. So, we get negative 10 meter. Alright, which means the particle is on the left of the point O away from 10 meter. Alright. Question number 7. A particle moves along a straight line from a fixed point P. Its acceleration a meter per second square at t seconds after leaving P is given by a equals to mt plus n, where mn are constant. The particle moves with an initial velocity of 30 meter per second, experiences a deceleration of 20 meter per second square, and stops when t equals to 2. Assume motion to the right is positive. A, we need to find the value of m and of n. Alright, from the information given, we have a equals to mt plus n, and we know that the initial velocity is 30 meter per second. So we try to get the velocity function by integrating the mt plus n with respect to t. So we get v equals to m over 2t squared plus nt plus c. And the initial velocity tells when t equals to 0, v equals to 30. So when t equals to 0, we know v is actually equals to c. Therefore, c is 30. Okay, so we know c equals to 30, and it experienced a deceleration of 20 meters per second or so. So when t equals to 0, our a equals to negative 20. So sub in the t equals to 0 into the acceleration function, we get n equals to negative 20. Okay, and then the particle stop when t equals to 2. So when t equals to 2, we will experience v equals to 0 because the particle stop. So sub the t equals to 2 into the velocity function that we got. We get m over 2 times 2 square plus, minus 20 times of 2 plus 30. We change the n into negative 20. So we'll get m equals to 5. B. Express the displacement function as of the particle in terms of t. We already have the velocity function, okay, and we write it with our mn. We'll get v equals to 5 over 2t squared minus 20t plus 30. If we need the displacement function, then we need to do integration with respect to time of the velocity function. Therefore, we'll get 5 over 6t cubed minus 10t squared plus 30t, and then we'll see the c equals to 0 because when t equals to 0, the particle is on the fixed point P. Alright, so this is our function of displacement. C. Find the value of t in seconds when the particle stops for second time. So when the particle stops, it means v equals to 0. And we get 5 over 2t squared minus 20t plus 30 equals to 0. We times by 2 so that I don't have fraction here. So we get 5t squared minus 40t plus 60 equals to 0. And we see common factor of 5 here. Therefore, everything divided by 5, we get t squared minus 8t plus 12 equals to 0. And now we can do factorization easily. With t minus 2 and t minus 6 equals to 0, we get t equals to 2 or t equals to 6. So the particle stopped for second times. This is the first time it stopped, and the second time is on t equals to 6 seconds. D. Calculate the total distance of the particle traveled in the second seconds. Alright, so we need to find the displacement of the second seconds and the first second. So sub in the t equals to 2 into our displacement function from here, and minus sub in the 1 in our displacement function. Okay, so since these two values are positive and we need to find the difference, we just minus. If we get a negative values here, don't forget to put your modulus. Alright, so we get 35 over 6 meter. Question number 9. Irma drive along a straight road after leaving the car park at a shopping complex. The velocity v meter per second of her car is given by v equals to 1 over 2t squared minus 2t, where t is the time in seconds after passing the automatic bar. The initial displacement of the car is 50 meter. A. Calculate the value of t in seconds when the car stops instantaneously. So when the car stops instantaneously, it means v equals to 0. So our function of velocity equals to 0, and we factorize 1 over 2t, we get t minus 4. Alright, equals to 0. So we get t equals to 0 or t equals to 4. So the car stopped instantaneously at t equals to 0 or t equals to 4. B. Find the total distance in meter of the car traveled in the first 7 seconds. Alright, so we know the car stops at t equals to 4, right? So we break our time interval for the first 7 seconds from 0 to 4 and for 4 to 7, because 4, when t equals to 4, that is the time when the car turns direction. Alright, so the displacement by integrating the velocity will get a negative on either one. Okay, after checking with the calculator and calculate, we know from 0 to 4, I'll get this displacement in negative. So it moved to the leftward. I need the total distance here. Therefore, I times a negative here so that I get the distance traveled in the first 4 seconds. Alright, so By integrating and sub in the 4 and 0, we'll get 16 over 3. Sorry, negative 16 over 3. After times negative, we get positive 16 over 3. And from 4 to 7, sub in the 7 and sub in the 4, we'll get 27 over 2. So the total distance will be 113 over 6 meter. C. Describe the movement of the car in the first 6 seconds. Right? Oops. So when t equals to 0, v equals to 0, and the s is 50 meter, right? So s is 50. T equals to 4, v equals to 0, and s will be equals to, we need to calculate, alright? The s will be negative 16 over 3. And when t equals to 6, our v, okay, sub in the t into the velocity function, I will get v equals to 6 meter per second, s will be 0, and the a, we need to integrate it and sub the 6, we get a equals to 4 meter per second square. So I will describe the movement of the car, okay, by the car start moving from point O when t equals to 0, okay, when t equals to 4, sorry, the car start moving from 50 meter away from fixed point O, okay, when t equals to 0. When t equals to 4, the car reaches minimum displacement of negative 16 over 3 meter and stop instantaneously with the acceleration of 2 meter per second square. So when t equals to 6, the car reaches back the point O with the with the velocity of 6 meter per second and the acceleration of 4 meter per second square. Alright? Question number 12. A particle moves along a straight line from an initial point. Its velocity v meter per second at t seconds after passing through the initial point is given by v equals to ht squared plus kt, where h and k are constants. The particle stopped instantaneously after 3 seconds with an acceleration at that time of 9 meter per second squared. Fine. Assume the movement to the right is positive, right? The value of h and k. So we are given v equals to ht squared plus kt, okay, and we need to link up all the information. When t equals to 3, v equals to 0, and a equals to 9, so we can get first point, okay, when t equals to 3, okay, v will be 0, and we'll get the relation of k and h. We know k equals to negative 3h. And then from the acceleration function, okay, we know a equals to 9 when t equals to 3. So we need to get the acceleration function from the velocity function by differentiating. So the a is actually 2ht plus k. And when t equals to 3, a equals to 9, we get 9 equals to 6h plus k. So we have two equations that relating h and k. So we can sub k equals to negative 3h into 9 equals to 6h plus k. So we will get 3h equals to 9 and h equals to 3. And the k is negative 3 times of 3, and we get k equals to negative 9. B. The time in seconds when the particle returns to the initial point. So when the particle returns to the initial point, which is it returns to the fixed point O, right? So the s will be 0. So get the function of s, okay, by integrating 3t squared minus 9t. And we'll get t cubed minus 9 over 2t squared plus 0 because the c is 0. Therefore, when s equals to 0, our t, alright, we can factorize out t squared and t minus 9 over 2 equals to 0. And from here, I know that t equals to 9 over 2 seconds. Okay, so when t equals to 9 over 2 seconds, the particle returned to the initial point. C. The acceleration in meter per second square when the particle returns to the initial point. So the particle returns to the initial point at t equals to 9 over 2, and we need to calculate the acceleration function. So the acceleration function is a equals to 2ht plus k, and the a equals to 2h is 3, t is 9 over 2 plus k is negative 9. Okay, I should rewrite my a so that easier. 2h, where we will get 2 times 3, alright, and t minus 9. So you will actually get 6 times of 9 over 2 minus 9, you will get a equals to 18 meter square. Sorry, you will get a equals to 18 meter per second square. D, the total distance traveled by the particle in the first 5 seconds. So in the first 5 seconds, we need to check, okay, whether the particle stopped instantaneously from 0 to 5. And from the very beginning, the question already tells the particle stopped instantaneously after 3 seconds with an acceleration of that time. So when t equals to 3, v equals to 0. Alright, so we'll break our first 5 seconds into 0 to 3 and 3 to 5. Okay, because we know either one of this will be a negative. So when we check with our calculator by integrating this and sub in the value of 3 and 0, we get negative 27 over 2 here. So we put a negative in front from the very beginning so that I will get positive 27 over 2 meter plus 26 here. Okay, after integrating and sub in the 5 and 3, I'll get 26 here. So we get the total distance traveled 79 over 2 meter. So the answer here is different from the textbook. Please take note. Question number 13. A particle moves along a straight line and passes through a fixed point O with a velocity of negative 6 meter per second. Its acceleration a meter per second square at t seconds after passing through O is given by a equals to 8 minus 4t. Assume the moment to the right is positive. A. Find the maximum velocity of the particle. Maximum velocity is the key. It tells a equals to 0, the dv dt equals to 0, which is a equals to 0, and we have our function a, 8 minus 4t equals to 0, and we'll get t equals to 2. And we want maximum velocity. We need to sub in the t equals to 2 into the function of velocity. So now we got to find the function of velocity by integrating the 8 minus 4t with respect to t. And we'll get v equals to 8t minus 2t squared plus c. And our initial velocity is negative 6. Therefore, v equals to 8t minus 2t squared minus 6. So the maximum velocity happened when t equals to 2, right? So maximum velocity equals to 8 times of 2 minus 2 times of 2 squared minus 6. And we get 2 meter per second. B. Find the time in seconds of the particle when it's past the fixed point O again. So when it passed the fixed point O again, means the displacement equals to 0. So we need to get the displacement function by integrating the velocity function. So integral the velocity function with respect to time, we get the displacement function equals to 4t squared minus 2 over 3t cubed minus 6t. So when s equals to 0, we factorize out the t, and we get 4t minus 2 over 3t squared minus 6. And everything's here times 3 on the left and on the right. Alright, so that we get 0 equals to t times of negative 2t squared plus 12t minus 18. So by factorize the negative 2 again, alright, then we get 0 equals to t times of t squared minus 6t plus 9. And factorize this, we'll get t minus 3 completely squared. Therefore, t equals to 3 seconds. This is the time when the particle passed the fixed point O again. Alright. C. Sketch the velocity time graph for the movement of the particle for t from 0 to 3. So when t equals to 0, our initial velocity is negative 6. So we will get negative 6 here, alright? And when v equals to 0, we'll try to get v equals to 0 and we'll get 1 and 3. Okay, so we need the movement from 0 to 3. We have all this. So I know I have maximum velocity, okay, happen in the middle of 1 and 3. It happens when t equals to 2, right? So we will get a set phase graph with the negative 2 here, okay, starting from negative 6 goes up to 2 and then comes down to 0. D. Then find the total distance in meter traveled by the particle in the first 3 seconds. So in the first 3 seconds, we know v happen to be 0 when t equals to 1. So I'll break the time gap of the first 3 seconds from 0 to 1 and 1 to 3. Okay, so by integrating the function of velocity, okay, we'll get 4t squared minus 2 over 3t cubed minus 6t, and sub in the 1 and 0. We get negative 2 and 2 over 3. So I know the integration of this part will be negative values. Therefore, I put a negative in front to make my distance positive. And the second part of the integration will get me positive 2 and 2 over 3. So the total distance now will be 5 and 1 over 3 meter. Question number 14. Teacher Aziza conduct an experiment to determine the velocity of the trolley along a straight track. The velocity v cm per second of the trolley after passing the fixed point O is given by v equals to t squared minus 7t plus 6. Assume the movement to the right is positive. A. Find number 1, the initial velocity in cm per seconds of the trolley. So when t equals to 0, alright, we'll get our v equals to 0 minus 7 times of 0 plus 6. So the initial velocity is 6 cm per second. Number 2, the range of time in seconds when the trolley is moving to the left. When the trolley is moving to the left, we will get velocity less than 0. We'll get a negative velocity. So velocity function, which is t squared minus 7t plus 6 less than 0, factorize it, we get t minus 1 and t minus 6 less than 0. So to get the solution of the quadratic inequalities, so we need to sketch this graph. We have a smiley face because of positive t squared, okay, and with the roots of 1 and 6. So the part of the expression less than 0, okay, is below the t-axis. Therefore, our t is between 1 and 6 seconds. Number 3, the range of time in seconds when the acceleration of the trolley is positive. So when the when the a is greater than 0, okay, when the acceleration is positive, so we need to get the function of acceleration by differentiate t squared minus 7t plus 6. We get 2t minus 7 greater than 0. So the t greater than 7 over 2. B. Sketch the velocity time for the movement of the trolley for the t from 0 to 6. So when t equals to 0, our velocity will be 6, right? And the velocity times graph will have a smiley face, alright? So we need to get the time when v equals to 0. So when v equals to 0, we know it happens when t equals to 1 and 6. Okay, and between 1 and 6, this should be my minimum velocity. Alright, so I'll get 7 over 2 by adding up the 1 and 6 divided by 2. Okay, so I need to know the minimum velocity here. Therefore, I sub in 7 over 2 into the velocity function, and I'll get my v equals to negative 25 over 4. So this is my complete graph of the velocity time, okay, with all the label, initial velocity of 6, alright, pass through v equals to 0 when t equals to 1 and 6, and then the minimum velocity happen on t 7 over 2, with the v negative 25/4. Question number 15. A particle moves along a straight line and passes through a fixed point O. The velocity v meter per second t seconds after passing through O is given by v equals to t squared minus 6t plus 8. The particle stops instantaneously at point P and R. Assume moving to the right is positive. A. Find the minimum velocity in meter per second of the particle. When we say minimum velocity, we'll get dv dt equals to 0, which is when A equals to 0. So we try to get the dv dt from here. So we'll get dv dt equals to 2t minus 6. And it happens when dv dt equals to 0, which we will get t equals to 3. Therefore, the minimum velocity happens when t equals to 3. So minimum velocity is t squared, which is 3 squared minus 6 times of 3 plus 8. And we get negative 1 meter per second. B. Calculate the distance in meter between the point P and the point R. So the particle stops instantaneously at point P and point R. So we need to find out when is the time the particles be in point P and point R. So when v equals to 0, our t squared minus 6t plus 8 equals to 0, and we get the time of t equals to 2 and t equals to 4. Right? So find the displacement of the particle in these two times. We'll get when t equals to 2, we need to get the displacement function by integrating the velocity function first. Alright? So after integrating, we'll get our complete displacement equation by s equals to t cubed over 3 minus 3t squared plus 8t. Okay, so when t equals to 2, we will get s is 20 over 3. When t equals to 4, the s4 will be 16 over 3. So we want the distance between point P and R. So we find the difference between the two displacements. So we'll get 4 over 3 meter. C. Sketch the velocity time graph for t from 0 to 7. Determine the range of values of t when the velocity of the particle is increasing. Alright, so first we need to sketch the graph of v equals to t squared minus 6t plus 8. Alright, so from the v equals to 0, we know that t equals to 2 and 4. Okay, so we will have our roots with 2 and 4. Okay, and we know this is a smiley graph. Start with the initial velocity of 8. Okay, when t equals to 0, our initial velocity is 8. So we will get a graph like this. And we stop at t equals to 7. Therefore, we need to find out what is the v when t equals to 7. So when t equals to 7, sub the 7 inside into the velocity function, we'll get v equals to 15. So this is the complete graph of our velocity time graph. Then we want the range of values of t when the velocity of the particle is increasing. So the v is increasing. We analyze the graph. For the first 3 seconds, the particle from velocity 8 meter per second drops until negative 1 meter per second. And when t equals to 3, it turns. Okay. When t greater than 3, he will increase the velocity. Therefore, the range of t when the velocity of the particle is increasing happens when t greater than 3.